Good morning, students. In the last class, we discussed about the classification of organic compound, and just I said only the chart that tells about the classification of compounds. Okay. So in that, I'll write once again the chart. So simply I'll say first organic compounds. That organic compound is classified into alicyclic, acyclic, and cyclic. Okay. So in that acyclic, that is aliphatic compounds. That means open chain or branched. Cyclic means it is alicyclic and aromatic compounds. Okay, in that aromatic compounds again benzenoid, sorry, alicyclic and aromatic both homocyclic is there, heterocyclic is there. So in that homocyclic and heterocyclic, one is benzenoid, another one is non-benzenoid. Okay, so this is all about classification. So I'll explain one by one. What are organic compounds first? Okay, so initially just I'll write the definition and example. Organic compound because important for humans. Carbon, carbon and its compounds with hydrogen and some other heteroatoms like oxygen, nitrogen, sulfur are called as aromatic compound. Sorry, are called as organic compound. Okay, so carbon and its compounds with hydrogen and some other heteroatoms like oxygen, nitrogen, sulfur are called as organic compounds. In that example, students, I'll write for an example that is all alkanes, alkynes, okay, cyclic compound, benzene, okay, benzene formula you know. Next furan means like this, okay. So and also this one is pyron. These are the example of organic compound. In that straight chain compound is also there, cyclic compound is also there, benzene aromatic is also there, hetero compound is also there. All type of carbon and its compounds along with oxygen, nitrogen and sulfur I said. Those are also organic compounds. So this is the definition. Understood? Next, so this organic compound is classified as these organic compounds mainly classified as. So the first one is acyclic. Acyclic means there is no cyclic structure. There is no closed structure. So what are acyclic organic compounds? Means the compounds open chain compounds are called as acyclic compounds. Okay, these are also called as these are also called as Aliphatic. Aliphatic compounds. So the name of those compounds are also called as what? Aliphatic compounds. Understood? So initially, these organic compounds classified mainly as acyclic and cyclic. In that acyclic means the open chain compounds are called as acyclic. There is no cyclic form closely. So these are also called as aliphatic compounds because the open chain compounds. So example for that is students, all alkanes. What is the alkanes formula means? That is CN H2N plus 2. Correct? Next, alkenes. General formula CN H2N. And also alkynes. Formula CnH2n minus 2. So these are the example for acyclic, that is aliphatic compounds. What are aliphatic compounds means? A open chain or a long chain or a branched open chain compounds. Understand? What are aliphatic compounds means? Long chain or branched open chain compounds are called as aliphatic compounds. Are you getting? Open chain. If you write the alkane, it will be like this. Maybe a branches are there like this. But they are open chain. They are not closed like this. They are not closed. The first and the last carbon atom. So listen, this is the first carbon atom, second, third, fourth, fifth. In between first and last carbon atom, there is no connection. Understand? If there is a bond between the first and the last carbon atom, then it is cyclic. If there is no connection, then it is acyclic. So that is open chain compounds. Second one is cyclic compounds. Second classification. First one is acyclic. Second one is cyclic. So listen, the closed and ring-like compounds. Okay. Instead of closed chain or ring-like compounds called as cyclic. Okay, so students, in this cyclic, and take an example. These may be called as alicyclic and do not aromatic. Both. Alicyclic is also a cyclic ring. Aromatic is also a cyclic. Alicyclic and aromatic. Okay. Next. So listen. Example for this if we take. I'll take this cyclopropane and this cyclobutane. Okay. Next. Cyclohexane. These are alicyclic compounds. Okay, so I'll take this benzene. Next, this furan. Now furan, NH is there, that is pyridine. Next, furan. Okay, these are all the examples for aromatic, but both are not cyclic because there is a bond between the first and the last carbon atom here. If you consider this as first, 1, 2, 3, 4. Of course, first and last carbon atom, they are interconnected. Here also 1, 2, 3. First and last carbon atom interconnected. This is a closed system, a closed structure. Understand? So this is what. So classification of organic compounds, that is acyclic and cyclic. Acyclic also called as aliphatic. Cyclic are also called as alicyclic as well as aromatic. Understand? Okay. Next one. Classification of this cyclic. Next one is cyclic compounds are classified as first one is alicyclic. Okay, so listen. The ring-like are closed chain compounds. Or you take inverse or closed chain compounds which shows similar properties like aliphatic compounds, called as acyclic, alicyclic compounds. Understood what it is? The ring-like are closed chain compounds which shows similar properties like aliphatic. Aliphatic means what are the examples there? Alkane, alkene and alkyne. Understand? Of course they are cyclic compounds but they show properties like aliphatic, like alkane, alkene and alkyne. I'll give the example, then you came to understand what is it mean. Okay. So listen students, example for this type is this one is cyclopropane. So initially I'll write before giving example. These have the general formula of alkenes, that is CN H2N is the general formula of cycloalkanes. Understand? Listen. Students, if I take here example of this cyclopropane, 3 carbon atoms are there, propane, cyclic in structure, that's why it is called as cyclopropane. So here, if you extend this structure, it is like C, 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 right? Here 2 carbon atoms are there means CH2, CH2, CH2. 2 bonds. So 4 bonds are satisfied with hydrogen means 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So then if you complete the structure, so completely combine the molecule, the formula becomes 3 carbon atom, 6 oxygen, sorry, 6 hydrogen atom. Okay, so this is CnH2n. That is what formula of that alkene, general formula of alkene. Next, if you consider this cyclobutane, here it is carbon, 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 carbon. Correct? Here two bonds are there, H2, two bonds are there, H2, two bonds are there, H2, here two bonds are there, H2. So if you write the formula 1, 2, 3, 4 carbon atom, that is C4, 2, 4, 6, 8 hydrogen atom, that is H8, that is also the formula CnH2n. Understand? So this is one alicyclic compounds, means the ring like are closed compounds, but they show the properties like aliphatic compounds like general alkane, alkene and alkyne. But they are closed structures. So if propane is there, this propane shows the, if it is cyclopropane and this general propane, CH3, CH2, CH3, both shows almost the same properties, but only the structure is different. This is cyclic, this is open chain. Understand? So the properties of this aliphatic and this cyclic compounds are same. So that type of compounds are called as alicyclic compound. Example for this is all cycloalkanes, and write examples for that. All cycloalkanes, cycloalkenes. Okay. Next, cycloalkanes. Understood? So this is the example for alicyclic compound. Understand, students? So the next one is aromatic. And just rub here examples. Second one is in cyclic, that is aromatic compounds. So what are these aromatic compounds? The ring-like compounds which doesn't show the properties like aliphatic compounds. Okay, the ring-like compounds which doesn't show the properties like aliphatic compounds. Means these are also closed system. These are also cyclic compounds, but that doesn't show any property like aliphatic compound, like open chain compound. What is the difference between that? Here both are cyclic, both are ring type, but this alicyclic shows same properties like aliphatic compound, but it doesn't show the properties like aliphatic compound. That is the difference between acyclic and alicyclic and aromatic. Understand? So aliphatic means it is this that doesn't show the properties like aliphatic compounds. So the best example for this is benzene. All the aromatic compounds starts from benzene. Okay, so this one is there. This pyridine is there. Again, pyrrole is there. Sorry, furan is there. This one is pyridine. Another one, anthracene is there, naphthalene is there. Okay, anthracene is also there. Okay, so these are the example of aromatic compounds. Understand? So this is classification of cyclic compounds, alicyclic and aromatic. So students, both these alicyclic and aromatic are classified as homocyclic and heterocyclic. Understand? Both cyclic compounds are classified as what? Homocyclic and heterocyclic. Okay? So I write what is homocyclic and what is heterocyclic. Susan. Next one is homocyclic. So students listen. This homo means what? Same. Okay. So this homo means same. Of course, if you explain, if you want to write the definition for this means cyclic homo. So cyclic compounds are a cyclic structure or a closed structure made up of or done by same type of atoms or only carbon atoms. You know what is organic compounds means? Carbon and its compounds. If cyclic structure is made up of or consists of unit, not made up of, we cannot make. Consists of only one type, especially carbon atoms. Only one type, especially atoms. Okay. Are called as homocyclic compounds. Okay, so students, example for this is homocyclic. As I told you, this homocyclic, that is alicyclic is also there, as well as aromatic is also there. Listen, only one type. Listen, this cyclopropane is there, that is made up of only carbon, that is homocyclic. Next, this benzene is there, that is made up of only carbon, that is correct. Next, this cyclopropane and benzene is there. Sorry, cyclobutane and cyclopropane are there. This is also made up of same type of carbon atom, means it is also example for homocyclic. Okay. Next you take naphthalene or anything else. All are made up of only carbon atoms. So this is example for what? Homocyclic. Understand? Next, what is heterocyclic? Heterocyclic. Listen, hetero means different. Okay, you cannot say if the cyclic structure consists of different type of atoms. It is not like that. Okay, if the cyclic compound consists of at least one atom, at least one atom other than carbon. You should mention, you cannot write the cyclic compounds made up of different atoms. It is wrong. Why? Because the organic compounds are all made up of what? Carbon compounds only. Hetero compounds means how? At least one atom is present other than the carbon. At least one. Understand? So if the cyclic compound consists of at least one atom other than carbon, called as heterocyclic compound. So listen, if I take the example, this one stands first. Listen here, this is the example for heterocyclic compound. Here carbon, 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 carbon is there. Fifth one is not a carbon. So one carbon is replaced by that oxygen. At least one atom is other than carbon. Now it cannot be like this. It is highly impossible. There is no one compound like this. It is highly impossible. Hetero compound means it is not about other than carbon. Okay. Of course, carbon is present because it is a aromatic organic compound. Organic compound nothing but carbon and its compounds along with the some hetero compounds. Okay, now? So, ideally, this compound oxygen, 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 it cannot form. It is highly unstable. It cannot exist also. Unstable is not a word. It cannot exist. Okay, so this is these four are the carbon atom. The fifth is the oxygen atom. So similarly, this is also example. NH. So your five carbon atoms are there. One is the nitrogen atom. Understand? So these are if you want to say cyclic, this is also correct. Okay, this is also correct. This is in alicyclic, these two are in aromatic. Understand? Okay, so this is homocyclic, this is heterocyclic. Homocyclic means the ring compound which is only made up of carbon, only carbon, not other. Okay, so here hetero means at least one atom is other than carbon, at least one. Okay, so this is heterocyclic. So students, in this homocyclic and heterocyclic compounds, especially aromatic compounds, they are classified as benzenoid and non-benzenoid compounds. This is all about cyclic. Next. Aromatic compounds are classified as first one benzenoid. Okay, benzenoid compound. So students, here if The compound consists of at least one benzene ring. At least one benzene ring are called as benzenoid compounds. Understand? If the compounds consist of at least one benzene ring, those are called as what? Benzenoid compounds. So example for that is, of course, alone benzene is a benzenoid compound. Okay, next. This one is also a benzenoid compound. At least one is the benzene ring. This cannot be exist, I am telling. If exist also, of course this is a benzenoid compound. Okay, next. This is also example for benzenoid. Understand? Next. This is also example of benzene because they consist of at least one benzene. Next. This is also example for benzene. They consist of at least one benzene ring. This is benzene, benzene, benzene. Understand? So second one is non-benzenoid. Then what will be the definition? What will be the definition then? Non-benzenoid. Can you? If the compounds doesn't contain benzene ring, but they show aromaticity. The compounds doesn't contain benzene ring, but they show aromaticity. So listen, example for that is this is the example, alternate, double and single bonds only. Or if you want to take, instead of here, you take here. This is what? Cyclooctane. Not octane, octane, tetrahydrides. Okay, next. Of course, this is not a benzene ring. Correct? This is not a benzene ring. Next, this one. This is aromatic. Okay? But this is not a benzene ring. Okay? Next. This is also aromatic, but it is not a benzene. Benzene means it is like this C6H6. If the compound consists of at least one benzene ring, then it is a benzenoid compound. If the compounds doesn't consist any benzene ring, but they exist aromaticity. Their conditions are there. What is the condition to exhibit aromaticity? Later I'll explain. Okay, some rule are there, two rules actually. First one rule is it must be a planar compound. Second one is it should satisfy 4n plus 5. 4n plus 1. 2 pi electron. This is called O'Callaghan 4n plus 2 pi rule. Okay, so these two are the conditions that tells about the aromaticity. If any compound satisfies these two, then it is aromatic. If it is benzene or other than benzene. Okay, later I will explain this aromaticity compound. It will come in the later concepts. Okay, just remember, if the compound doesn't contain any benzene ring but they exhibit aromaticity, then they are called as non-benzenite compounds. So this is all about the classification of organic compounds. Understand? So their classification and definition is very, very important. Okay, students, I'll repeat the definitions once again, then you will come to know. So listen. So before going that, later I'll explain homologous series. Initially, listen. If any compounds, the carbon and its compounds other than hetero compounds like oxygen, sulfur, nitrogen, etc. are called as organic compounds. Organic compounds are classified mainly as two types. One is acyclic, another one is cyclic. Acyclic means, in that acyclic, straight chain acyclic means, A means that is opposite, cyclic means ring type structures. So acyclic means they are not ring, they are not closed system. Understand? So they are open chain compounds. So the open chain compounds are a straight chain or a branched compounds are called as acyclic and also called as aliphatic compounds. Example for that is straight chain alkanes, alkenes and alkynes. All alkane, alkene and alkene. Okay, cyclic means the ring-like closed structures are called as cyclic compounds. Okay, in that cyclic compounds, there is an interconnection between the first and the last carbon atom. Okay, so there resembles the general formula CnH2n, that is that is alicyclic, right? So those are all cyclic compounds. Those cyclic again classified into alicyclic and aromatic. Okay, what is alicyclic? What is aromatic? So I'll say alicyclic means the cyclic compounds which shows the property of aliphatic compounds. Okay, cyclic compounds which shows the property of aliphatic, then it is alicyclic. The cyclic compounds which doesn't show the property of aliphatic, then it is aromatic compounds. Okay, so in that two types is the homocyclic and heterocyclic. Homocyclic means homo means same. If the cyclic compound is made up of same type of atoms, that is especially carbon atoms, only carbon atoms, then it is homocyclic. What is heterocyclic means the atom or a cyclic system or a cyclic compound made up of or consists of at least one different atom other than carbon. Okay, so that is called as heterocyclic. At least one atom other than carbon. That is called heterocyclic. So in that aromatic, benzenoid is there, non-benzenoid is there. What is benzenoid means? The compound consists of at least one benzene ring, that is benzenoid. It doesn't contain any benzene ring, but it shows aromaticity, then it is non-benzenoid. Okay, this is all about classification. So in the tomorrow's class, I'll explain homologous series, functional group and everything. And it means from tomorrow I'll explain the nomenclature, how to name the compounds. That is very important. It takes too much time to understand you, and I'll go with very slow manner.